Something insane is about to happen, and unlike every storm this channel has ever covered, you cannot see this one coming on any radar. There is no funnel cloud. There's no spinning red blob on satellite. What is coming is already in motion right now, hidden beneath the surface of the Pacific Ocean, a mass of abnormally warm water so enormous that it is measured in thousands of miles, rising toward the surface like a slow-motion tidal wave of heat. And when it fully arrives, it will not hit one town or one coastline. It will reach into the life of every single person watching this video. Your winter, your storms, your grocery bill, the hurricane season, possibly the global temperature record for the entire planet. Because the data coming in over the last few weeks has pushed forecasters toward a conclusion they do not reach lightly. The event now developing in the Pacific is trending toward becoming one of the strongest of its kind in modern recorded history. They call the phenomenon El Niño. And when it crosses a certain threshold of intensity, forecasters reach for a bigger word, Super El Niño. The last 3 times the ocean did what it is doing right now, the years that followed brought some of the most extreme weather ever recorded on this planet, and one of them produced the hottest year in the history of measurement. But here's the twist that makes 2026 different from every previous event, the part that has long-range forecasters genuinely fascinated. This time, the Pacific is not acting alone. On the other side of the continent, in the Atlantic, something rare is emerging at the exact same moment, a cold anomaly with its own name and its own consequences. And the collision of these two ocean giants is about to write the script for the next 12 months of weather across North America. I am your name, and this is your channel. If you want to understand the forces that will actually shape the year ahead, not hype, just the real data, subscribe right now. Because this is a story we will be tracking all the way through winter. Now let me show you what is happening out there, because once you see it, you will never look at a seasonal forecast the same way again. To understand what is developing, you need to understand the single most powerful weather-making machine on Earth, and it is not a hurricane. It is the tropical Pacific Ocean. Stretching along the equator from South America to Asia lies the largest expanse of warm water on the planet, and under normal conditions, steady trade winds blow across it from east to west, physically pushing the sun-heated surface water toward Asia and piling it up there in a deep, warm pool, while cold water rises from the depths along the coast of South America to replace it. That arrangement, warm in the west, cool in the east, anchors the thunderstorms, the jet streams, and the rainfall patterns of the entire globe. El Niño is what happens when that machine breaks. The trade winds falter or even reverse, and when they do, that gigantic pool of warm water that was being held in the western Pacific is released, sloshing back eastward across the ocean in slow, massive underwater surges called Kelvin waves. That is not a metaphor. It is exactly what the ocean sensors have been recording this year, a powerful oceanic Kelvin wave driven by bursts of westerly winds, carrying a huge reservoir of subsurface warmth eastward and upward toward the surface of the eastern Pacific. And here is what makes 2026 remarkable. For the past several years, the Pacific was locked in the opposite phase, La Niña, the cool pattern that shaped season after season of our weather. This year, that multi-year La Niña did not fade gently. It collapsed fast, and the ocean swung hard the other way. On June 11th, the National Weather Service made it official. El Niño conditions are present, and they added the phrase that turned this from a routine climate update into the story you are watching now. The data supports the possibility of this event reaching Super El Niño status as the year goes on. Since then, update after update has trended the same direction, stronger, faster, with some of the latest analyses suggesting an event that could challenge the strongest in the modern record. Forecast agencies around the world are seeing similar strength signals, and when independent models from different countries converge like that, confidence rises that something historic is genuinely on the table. Before we get to what it does, take 1 minute on how we even know all this, because the monitoring system behind this story is one of the most underrated scientific achievements on the planet, and the name itself carries a clue about how long humans have been watching. Centuries ago, fishermen along the coast of Peru noticed that every few years, around Christmas, the cold, fish-rich waters off their shore would turn strangely warm and the fishing would collapse. Because it arrived near the holiday, they named the phenomenon after the Christ child, El Niño, the boy. That folk observation, passed down through generations of fishermen, turned out to be the local symptom of the largest natural climate cycle on Earth. Today, the watching is done by machines, and on a scale that is hard to fathom. A network of moored buoys stretches across thousands of miles of the equatorial Pacific, each one dangling strings of sensors hundreds of feet down into the ocean, measuring temperature not just at the surface, but deep below it, where events like this one hide before they strike. That is how forecasters saw this coming months ago, because a Super El Niño announces itself underwater first. as a huge lens of anomalous warmth sliding eastward beneath the surface, invisible from above, unmistakable to the sensors below. Satellites add the view from space, tracking sea surface temperatures and even the height of the ocean itself, because warm water physically expands and literally bulges the sea surface upward by inches, a bump you can measure from orbit. All of that data funnels into one number you will hear constantly in the coming months, the temperature anomaly in a patch of ocean called the Niño 3, 4 region, the central equatorial Pacific. An anomaly of half a degree Celsius above normal, sustained, is the official doorway into El Niño. A degree and a half marks a strong event. In the informal club of Super El Niños, the 1982, 1997, and 2015 class begins around 2 degrees Celsius above normal, a number that sounds small until you remember it describes extra heat spread across an area of ocean bigger than the United States. That is the threshold the current forecasts have this event flirting with. So what does a Super El Niño actually do? For that, we do not need speculation. We have 3 case studies because the ocean has done this 3 times in the modern instrumental era, and each one left scars. The first was 1982 into 1983, an event so far beyond anything scientists had measured that some initially distrusted their own instruments. It scrambled global weather, fueling catastrophic flooding in parts of the Americas, while droughts and fires ravaged the other side of the Pacific, with worldwide damages running into the billions. The second was 1997 into 1998, the event that made El Niño a household name. California was hammered by relentless winter storms and flooding. The southern United States was drenched, mudslides buried highways, and globally it was blamed for tens of billions of dollars in damage and thousands of deaths across multiple continents. The third was 2015 into 2016. That event helped drag the entire planet to what was then the hottest year ever recorded, triggered one of the worst global coral bleaching events in history, and rearranged rainfall from Africa to Indonesia to the American Southwest. 3 super events, 3 years the record book set aside. That is the class of event the 2026 Pacific is currently trending toward, and it is why forecasters who are normally allergic to drama are using words like atmospheric reset. And there is one more layer that makes this attempt different from all 3 of those. Every previous Super El Niño erupted on top of a cooler planet than the one we live on now. This one is building on the warmest baseline in the history of measurement. When the 2015 to 2016 event added its temporary spike of Pacific heat on top of the long-term warming trend, the combination set a global temperature record. If this event reaches the strength the data now suggests, scientists widely expect the same mechanism to push the planet into record territory again across late 2026 and 2027, not as a doomsday claim, as arithmetic. A warming baseline, plus the largest natural heat release the ocean can produce, has a predictable sum. And here's the thing. You do not have to wait to see this event's fingerprints, because it is already shaping the summer you're living through right now. Climate scientists were explicit when El Niño conditions were confirmed in June. Expect higher temperatures and a greater likelihood of heat waves. Weeks later, a heat dome broke records that had stood since the 1800s across the east, then rebuilt over the plains, where it is baking the middle of the country as I record this. El Niño did not create that dome by itself, but it loaded the dice underneath it. Look at the oceans, and the signal is even louder. The eastern Pacific hurricane season, which El Niño supercharges by warming its waters, has been churning out storm after storm, 5 named systems already with more developing, while the Atlantic, which El Niño suppresses, has managed exactly 1, and even that one, Arthur, was a rain event more than a wind event. That lopsided split, a hyperactive Pacific and a strangled Atlantic, is one of the most classic El Niño signatures in all of meteorology, and it is already on the scoreboard in July. The mechanism on the Atlantic side is wind shear. El Niño's displaced Pacific thunderstorms reroute the high-altitude winds over the Atlantic basin, tearing at developing tropical systems, tilting them, venting their heat, decapitating them before they organize. It is a hostile environment for hurricanes, and it is strengthening as the event grows. And to really grasp why a patch of warm Pacific water can reach into your life from thousands of miles away, you need one concept, and it is the most important idea in all of seasonal forecasting. Teleconnections. Here's the chain, step by step. Thunderstorms in the tropics are not just local weather, they are the pistons of the global atmosphere, towering engines that pump enormous amounts of heat from the ocean surface into the high atmosphere. Under normal conditions, the biggest cluster of those engines sits over the warm pool in the western Pacific. When El Niño drags the warm water eastward, the thunderstorm engines physically move with it thousands of miles across the ocean. And when you relocate the largest heat pumps on the planet, the high-altitude winds they feed, the jet streams get bent into new shapes, and those bends propagate around the entire hemisphere like ripples from a boulder dropped in a pond. A displaced storm cluster over the central Pacific becomes a strengthened subtropical jet over Texas, becomes a rearranged storm track over the Atlantic, becomes a shifted rainfall pattern over Africa. One cause, global effects, which is why forecasters can look at ocean temperatures near the dateline and make meaningful statements about winter in Tennessee. And the dominoes do not stop at American borders. In past super events, while the eastern Pacific side of the world flooded, the western side burned, with Indonesia and Australia plunged into drought and haze-producing fires as their rainfall engine literally sailed away from them across the ocean. The Indian monsoon, the rains that feed over 1 billion people, has historically faltered in strong El Niño years. Parts of Africa flip between drought and deluge. Marine heat waves ripple through the Pacific, disrupting fisheries from Peru to Alaska, which is the very effect those Peruvian fishermen named centuries ago. Global food prices, insurance markets, and disaster budgets all feel a super event, which is why governments and industries on every continent are reading the same buoy data you're hearing about right now. When forecasters call this an atmospheric reset, that is not YouTube language. That is the professional term for a rearrangement of the whole board. Which brings us to the second ocean giant, the twist I promised you, and honestly, the part of this story that made me want to make this video. While the Pacific swings hot, something rare is happening in the tropical Atlantic. The waters along the equatorial Atlantic have swung unusually cold, an event with its own name, an Atlantic Niña. These are far less famous than their Pacific cousins. They are smaller, rarer, and shorter-lived, but their effect on hurricane season points in one unmistakable direction. Cooler tropical Atlantic water means less fuel, more stable air, and an even harder environment for storms trying to develop in the deep tropics. So stack the deck as it now stands. A strengthening, possibly record class, El Niño pouring sheer across the Atlantic from the west. A rare Atlantic Niña cooling the storm nursery itself, and plumes of dry, dusty Saharan air smothering tropical waves as they roll off Africa. Long-range hurricane forecasters looking at that combination have slashed their seasonal outlooks, with the latest projections for accumulated cyclone energy, the index that measures a season's total storm output, coming in well below normal, potentially one of the quietest Atlantic seasons in recent years. Some analysts have gone as far as calling this dual ocean setup an atmospheric shield over the American coastline. And now I have to do the thing this channel exists to do, and put a giant flashing warning label on that phrase. A shield against a hyperactive season is not a shield against a hurricane. The quietest analog year everyone cites is 1992, a suppressed El Niño-flavored season that produced only a handful of storms, and one of them was Andrew, which annihilated parts of South Florida as a Category 5 and stood for decades as the costliest hurricane in American history. Seasonal forecasts predict the volume of storms, not the fate of your street. It only takes one, and homegrown systems spinning up close to the coast like the one we watched develop in the Gulf just this week can thread through a hostile basin and still put water in living rooms. If you live on the coast, you prepare this year exactly like every year. The shield lowers the odds, it does not repeal them. If this kind of no-hype context is what you want more of, hit subscribe right now, because the next part is the forecast for what comes after summer, and it is where this gets genuinely wild. Because a super El Niño saves its main performance for the cold season. That is when its grip on the jet stream tightens and the long-range models are already sketching the outline. The classic strong El Niño pattern goes like this. The subtropical jet stream, the southern branch of the river of air that steers storms across North America, gets amplified, energized, and loaded with Pacific moisture. That fire hose aims across the southern United States, historically bringing above normal rain and storm activity to California and the West Coast, the southern plains, the Gulf states, and the southeast through fall and winter. The same corridor that flooded in 1997 and 1998. Meanwhile, the northern branch weakens its usual grip, often leaving the northern tier of the country milder and drier than a normal winter. And the freshest seasonal model runs for this fall are showing something that has long-range watchers leaning toward their screens. An El Niño-driven pattern that looks almost winter-like, arriving early in autumn, and then strengthening steadily into January, with the strongest signals of the whole forecast landing in the heart of winter. On top of that, forecasters are tracking a third ocean anomaly, a returning pool of unusually cold water in the far North Atlantic, the so-called cold blob, a feature that in past years has preceded specific jet stream and pressure patterns over North America and Europe. 3 ocean anomalies, the Pacific running historically hot, the tropical Atlantic running rare event cold, the North Atlantic growing its cold blob, all locked in at once heading into winter. That tri-ocean setup is the reason this video has the title it has. Patterns this strongly forced do not guarantee any single outcome, but they stabilize the dice. They make the season more predictable and more likely to commit hard to its script. And the script currently being written features a stormy, soaked southern half of the country. A volatile fight along the middle and a winter that arrives with an agenda. There are even early warning signs being discussed around the polar vortex for the deep winter, and we will cover that in its own video when the data firms up, because that topic deserves rigor, not clickbait. Now the honesty section, because this channel does not do prophecy. What you have just heard sits at different levels of confidence, and you deserve to know which is which. That El Nino conditions exist right now, confirmed, official, done. That the event is strengthening rapidly with a large reservoir of subsurface warmth still to surface. That is direct observation, high confidence. That it reaches full super El Nino status by the second half of the year. That is a forecast, a well-supported one with multiple independent models in agreement, but a forecast, and ocean forecasts made in summer, carry real uncertainty. The seasonal impact maps for fall and winter, those are probability shifts, not promises. They tell you which way the dice are loaded, never how a single roll lands. And one thing requires saying plainly, because every time an event like this develops, the internet fills with claims that it is artificial, engineered, caused by weather weapons or secret programs. No. El Nino is one of the oldest documented natural cycles on Earth. Peruvian fishermen named it centuries ago. Its physics are textbook oceanography, and chasing those theories only distracts from the preparation that actually matters. So let us end there on what this means for you. If you are in California or anywhere along the southern storm corridor, this is the year to take winter seriously before it arrives, clear the drains, check the roof, know your flood risk, because strong El Nino winters have historically been when the atmospheric rivers line up and fire. If you are along the Gulf or Atlantic coast, ignore every headline about a dead hurricane season and keep your plan current, because 1992 is permanently on the record as the rebuttal. If you are in the northern tier, a milder winter may sound like a gift, but El Nino winters are famous for sudden whiplash exceptions, and we will track everyone. And wherever you live, understand that the heat this event adds to the planet works its way into everything downstream, growing seasons, energy demand, water supplies, and the price of what ends up on your table. The insane thing about what is happening right now is not any single storm. It is that the ocean has quietly made a decision, thousands of miles wide and months in the making, and the rest of us are about to live inside the consequences. And for the first time in one of these events, we have the satellites, the sensors, and the models to watch every move it makes in real time. That is exactly what this channel is going to do. Subscribe and turn on notifications right now, because the fall and winter updates on this pattern are going to matter more than any videos I make this year. Drop a comment telling me where you live and what your winters were like during the last big El Nino, because those memories from 1997 and 2015 are genuinely valuable data for everyone watching. And share this with someone who plans anything around the weather. A farmer, a coach, a traveler, a parent, because the next 12 months are not going to look like the last 12. And the people who understand why will be the ones who are ready. Thanks for watching.